All right, in this video, we are going to find the intervals on which a function is increasing and then decreasing. Our function is f of x equals 5x cubed divided by 3x minus 1. So the very first thing that you want to do in this kind of problem is to find what the domain of f is. This is a rational function. And so the domain of a rational function is going to be the set of all real numbers where the bottom one is not equal to 0, okay? That are not zeros of this bottom polynomial. So what you want to do is set the bottom part equal to 0 and solve that out. So do that over here off to the side. So set the bottom part equal to 0 and solve that out. So you get 3x equals 1. So x equals 1/3. Okay. So the domain here is going to be the set of all real numbers except positive 1/3. All right. So in interval notation, that would be negative infinity to positive 1/3 union 1/3 to infinity, like so. All right. So now that we have the domain, what we want to do is to take the derivative. And to take the derivative of this, we're just going to use the quotient rule, right? So it's going to be low, which is 3x minus 1, the bottom function, d high, the derivative of the top function. That's going to be 15x squared using the constant multiple rule and the power rule to take that derivative, right? So it'll be 5 times the derivative of x cubed, which is 3x squared. So that 5 times 3 will give you that 15. All right, and then minus high, which is the top function, 5x cubed, d low, that's the derivative of the bottom function. The derivative of this bottom function is just 3. Okay, and of course that's going to be all over low squared, so all over the bottom one squared. Okay, and next is to clean that up as much as you possibly can. All right, so I'm going to take and distribute this 15x squared through the parentheses. So I get 45x cubed. Right, that's 15x squared times this 3x minus 15x squared. And then minus 15x cubed. And that's going to be all over three x minus 1 quantity squared. All right, and then combine your like terms. You are going to get, here I have 45x cubed minus 15x cubed. That's going to be 30x cubed minus this 15x squared all over 3x minus 1 quantity squared. Okay. All right. So here is the derivative simplified as much as possible. The next thing we want to do is to solve the inequality 30x cubed minus 15x squared all over 3x minus 1 quantity squared greater than 0. Okay. In other words, we want to solve the derivative greater than 0, right? Is what we want to do to figure out where f is increasing, where f is decreasing. So that is a rational inequality. This is a rational function, right? And so what we're going to do to solve that out is to set the top equal to 0 and set the bottom equal to 0. okay, and solve each of those equations. All right, so let's go over here to this first one, this polynomial equation. What we want to do is to factor it as much as we possibly can. The first step in factoring, right, is to factor out the greatest common factor. So looking at the numbers, we have 30 and 15, so we can factor out that 15. Looking at the x's, we have x cubed here and x squared here, so we're going to be able to factor out an x squared. So when we do that, we get 2x minus 1 equals 0. All right. So next up then is we have this completely factored. We want to set each of these factors equal to 0. So 15x squared, set that equal to 0. Set the 2x minus 1 equal to 0. And solve each of those out. All right, so on this one, we'll divide both sides by 15. Now we get x squared equals 0. All right, and I'm kind of running out of room. But if x squared is equal to 0, if I square a number and I get 0, the only way in which that can happen is for x to be 0. So I get x equals 0 as a solution to this equation. Then this one, I get 2x equals 1, right? And so x equals a half. All right, and so that's all of the solutions of this equation over here. Next up, we need to solve this equation, 3x minus 1 quantity squared equals 0. So again, if I square something and I get 0, that means that whatever I was squaring had to be 0, right, in the first place. So here I'm squaring 3x minus 1 and I get 0. That means that 3x minus 1 has to be 0, right? That's the only way that that can happen. If you square any other real number, you will get a positive number, right, and not 0. And so I get 3x equals 1. So x equals 1/3, okay? All right, so I get these possible critical numbers. I get, let's see, where can I write that? Right here. I get possible critical numbers of 0, 1/2, and 1/3. Okay. So I need to take all of these possible critical numbers and put them on a number line that represents the domain of f prime. All right, so I'm going to do that right here. All right, so I'm going to put 0 right here and make sure that you respect the order, right, of the number line. 1/3 is in between 0 and 1/2. I kind of wrote that too far over, so let me redo that. And then extend this a little bit more and put 0 over here. Okay, so there's my number line. I put all of my possible critical numbers on there. All right, and at this time, it is a good moment to go ahead and figure out which of the possible critical numbers are actually critical numbers, okay? So the way we check that is just by checking to see if they are in the domain of the original function f. And we can see, right, that the original the domain of the original function f is all real numbers except 1/3. So that means 0 is in the domain, 1/2 is in the domain. So they are going to be critical numbers of f, but not 1/3. Okay, 1/3 is not a critical number of f. It still needs to be on the number line. Okay, all of the possible critical numbers need to go on there. Okay, all right. And so what we can see now is that those possible critical numbers divide the number line up into 4 pieces, right? This piece here, this piece in between 0 and 1/3, this piece in between 1/3 and 1/2, and this piece over here to the right of 1/2. So what I'm going to do is I need to pick test numbers on each of these pieces over here. So on this piece over here to the right of 1/2, I'm going to pick 1. That's nice and easy. In between 1/3 and 1/2, right, I am going to have to pick a number that's in between there. So 1/3 as a decimal is 0.3 repeating, and 1/2 is 0.5 as a decimal, right? So I'm just going to pick some number that I know is in between there. So I'm going to go with 0.4. Okay. Same thing over here. I've got to pick a number that's in between 0 and 1/3. So I am going to pick 0.2, right? Because 1/3 is 0.3 repeating. And then finally, I need to pick a number that is to the left of 0. So over there, I'm going to pick a -1. I'm going to have to erase some of this over here because it's getting kind of crowded in there. And so I'm going to pick a -1 to test over here. All right, and I am going to plug those numbers into this original inequality right here. All right, those test numbers, so I'm going to be plugging them into 30x cubed minus 15x squared over 3x minus 1 quantity squared greater than 0. Okay. All right, so I'm going to start off with the 1. Okay. So when I plug the 1 in there, I get 30 times 1 cubed minus 15 times 1 squared, and then 3 times 1 minus 1 quantity squared. I want to see if that's greater than 0. All right, so on top, I'm going to get 30 minus 15. On the bottom, I get 3 minus 1, which is a 2. And 2 squared is going to be 4. So I wind up with 15 over 4 is greater than 0. Okay? And that is a true statement, right? 15/4 is a positive number. It's bigger than 0. So what that means is that 1 is a solution to this inequality. And furthermore, right, it means that every number, right, on this piece over here, every number that's bigger than 1/2 is also a solution of this inequality because it's all or nothing on each piece, right? Either every number is a solution or no number is a solution. All right, so we know now that every number on this piece is a solution. What that means is that in order for a number to be a solution of this inequality, right, it would have to be a positive number right here, because that's the only way you're going to be bigger than 0. So that means that if I take any number on this piece, plug it into the derivative, I will get a positive. So what I do is I just mark through that test point because I really don't care about the test point from here on out. What I care about is the fact that if I take any number on this piece over here on the end, when I plug it into the derivative, I am going to get a positive number. And that means that the original function is going to be increasing on this piece. Okay. All right. Let's go with the -1. That's going to be the next easiest one to plug in. So I'm going to erase some of this down here at the bottom. All right, so I'm going to take this inequality and I'm going to plug in a -1. So I'm going to change all those to -1s. On the top here, I have negative 1 cubed. So that is going to be a negative 1. Negative 1 times 30 is negative 30. Here I have negative 1 squared, so that will be a positive 1, and a positive 1 times a negative 15 is a negative 15. And then here I have 3 times negative 1, that's going to be a negative 3. Negative 3 minus 1 is a negative 4. And negative 4 squared is a positive 16. All right, and so simplifying that out, I get a negative 45 on top. I get a 16 on the bottom. And so that means that negative 1 over here is not a solution of this inequality, right? Because a negative number is not greater than 0. So this is false. That means that negative 1 is not a solution to this inequality. Because it's all or nothing on each one of these pieces, right? That means that no number to the left of 0 is a solution to this inequality. And so what that means is that when I plug any number on this piece into the derivative, I will have to get a negative number. So to illustrate that, I mark it with that interval with a minus sign. All right, so that's a minus right there. Okay, next up I am going to plug in the 0.4 and the 0.2. Okay, so that is going to be a little bit difficult. I don't want to have to use a calculator to cut back and forth between this video and the calculator to do that because it's a little bit awkward. And plus, I also want to show you a trick on how to do this to save a little bit of time. Really all I care about is whether I get a positive or negative, right, into this equation, all right, because I'm using the sign of this to label those intervals, okay. And so if you look at the bottom, right, 3x minus 1 quantity squared, because you're squaring that, right, if I take any number other than a third and plug it in here, I will get a positive number. So I know no matter what that the bottom number is going to be positive, right? So I really don't care exactly what the number is. All I care about is whether it comes out to be a positive or negative. So what I'm going to do is instead of plugging it into the original, right, completely, I am just going to put a plus here, and that will make me realize, hey, the bottom part comes out to be a plus no matter what. And for 0.2 and 0.4, it's hard to do that exactly in my head. So what I'm going to do is I'm going to plug it into this top part right here. You can see that this top part, 30x cubed minus 15x squared, it exactly factors to 15x squared times 2x minus 1. So instead of using 30x cubed minus 15x squared on the top, I am going to use 15x squared times 2x minus 1. Right, because that is exactly equal to what I have on top. Now you have to be careful when you do that. It has to match this exactly. But here I am 100% certain, right, that these match exactly. And then also I can see up here on top that 15x squared, again, as long as I am not plugging in 0, that is going to come out to be a positive number. So I can just consider that as a positive. So that's going to make the math easier for me to do in my head, to do 0.2 and 0.4. If you don't like doing it that way, remember you don't have to do it that way. You could just plug it into your calculator and see what you get, okay? All right, so when I plug in the 0.4, I'm going to get a positive number times 2 times 0.4 minus 1 all over some other positive number. Okay, and I want to see whether that's greater than or equal to 0. All right, well, 2 times 0.4 is 0.8 and 0.8 minus 1 is minus 0.2. So what I end up having is a positive and negative on top and a positive on the bottom. When I multiply all that out and simplify all that out, it's going to come up to be a negative number, right? Because a positive times a negative divided by a positive is going to wind up to be negative. So with the 0.4, right? This is going to come up to be a minus up here. Okay. And then lastly, I need to test this 0.2. So I'm going to basically do the same thing. I'm going to plug a 0.2 in here. When I plug in a 0.2, right, I get 0.4, and 0.4 minus 1 will be minus 0.6. All right, and so again, I'm going to have a positive and negative on top. That will give me a negative on top. A negative divided by a positive will come out to be a negative. So this is what we get when we do that. Okay. So that's what our sign diagram looks like for this. Okay, and so once we have that sign diagram, then basically we can read our answer for this problem right off of that sign diagram. All right, so let me make some space here. Okay, so first off, for increasing, I'm looking for the intervals where there's a positive number. So you can see it's this one right here, 1/2 to infinity. And that's it. Now, in my class, if you're a student in my class, then you just put parentheses on everything. You don't have to worry about whether it should be a bracket or not. The details of that can be a little bit tricky. So I just tell everybody to put a parenthesis on there. But if you have another teacher, then they may want a bracket here. Or if you're working through a book, you may see parenthesis or bracket. In textbooks, I've really seen it to be inconsistent, right, with a lot of the answers in there, which is a little bit frustrating. So so that's one of the reasons why I just say, hey, just put parentheses here. So if you're taking my class, this is always going to be a parenthesis, but if you're in somebody else's class, then you may have to figure out whether there's a bracket or parenthesis on this one. All right, and then for decreasing, I'm going to put each of these intervals here. So this first one over here, I'm looking for the intervals for decreasing. It's going to be the intervals where there's a negative sign over it. So the first one is going to be negative infinity to 0. That's this one right here. The next one is going to be 0 to 1/3. And the third one is going to be 1/3 to 1/2. Okay. And again, there's an issue on these with the parentheses and the brackets. You might say, you also might say, can I combine these, right? Because look, isn't it essentially decreasing from minus infinity to all the way over here to 1/2? So you have to be, again, very careful about that. It's okay, in my opinion, to make it say it's decreasing from minus infinity to 1/3, right? Because, and then now that also depends on what book you're using. In my class, right, just leave it like this. That's how the answers are going to look on the quiz. Okay, so you can just see, that it looks like that way. So on the quizzes, I won't combine these. Although here you could argue that these could be combined into one. The one thing you can't combine, right, is this 1/3. You can't say that it's decreasing on that interval because 1/3 is not even in the domain, right, of this function. So again, in my class, I'm pretty loose about how this goes, about combining these um, and whether or not these should have parentheses or brackets on there. Okay. All right, and that is it on this one.